then we will do whatever problems we need to do. There are a few I want to go through with you. So, if you would find review sheet 2, which is page 8 of your packet, review sheet 2, page 8. Want to remind you that it'll be several days before we take our test, so it would behoove you to practice a little bit between now and then. Everything is on video now. Once I get this done, everything will be on video in terms of the review sheets. So I'm on review number 2, and I'm going to start at the bottom and work my way up. All right? So I'm going to start with the very last problem, which is what, 5D. And it says the math department wants to minimize the amount of poster board needed for something. Okay, we want to have 144 square inches of print, and we're going to have margins of 1.4 inches on the left, 2 inches on the top, 1.75 inches on the bottom and the right. Okay, I think we may have done one like this the other day, but I can't remember for sure. And we want to minimize the area of the whole thing. So to find the area of the whole thing, I need this dimension and this dimension. Would you agree with me? Multiply those two together, that will give me my area. All right, now what do I know about this dimension? Well, I know for sure it has a 1.4 and a 1.75. But it also has this, right? And I don't know what that is, so I'm going to call it X. So this dimension is 1.4 X and 1.75, which, where do I get when I add those together? 3.15? So that's X plus 3.15. Everybody still okay with that? Now, I'm going to do this dimension. All right, I know it's got a 2, and I know it's got a 1.75, but it also has this. Now, keeping in mind that the area of that little square is 144, if this piece is X, what would this have to be? No, it's not X because I don't know that it's a square. I know I said the word square, but I don't know that that's square. So I can't call it X.
144 over X?
144 over X. Because these two times together have to give you 144. So what do you multiply by X to get 144? 144 over X. The length is the area divided by the width. You can think of it like that too. So this dimension is 2, 144 over X, and 1.75. So it's 144 over X plus 3.75. Now this, I didn't mark it very well on the paper, but this is a calculator problem. All of these are. All these word problems are calculator problems. So I'm going to go to my calculator. And keeping in mind that X is this, I'm going to set X min at 0. And keeping in mind that Y is the area, I'm going to set that at 0. And the other ones I don't know, so I'm just going to leave them alone for a minute. I'm going to type in my equation exactly the way I wrote it. I'm not seeing anything, so I don't think my window's big enough. So I'm going to let X max be, I don't know, 50, and Y max be 1,000. Let's see what happens. Oh, that's not too bad, actually. So I just randomly, I let X max be 50, and Y max be 1,000. And I got a picture that looks like this. Now, what am I looking for? What does the problem say? What am I looking for? Minimum. Minimum. So that's a good thing, because I don't see the top of the hill, but I do kind of see the bottom of the valley here. So what do? Second calc. Go down to minimum. Set my bounds. See if yours matches. Mine came out to be actually about 11. If I round it off, it's 11, 238.3. Now, what does the 11 stand for? Well, now that's X. What does X stand for? The width of the print, right? The width of this little box in here. What does the 238 stand for? That's Y. What did Y equal? Area. So what's the answer to the question? 238.3 square inches, or whatever our unit is. Yeah, square inches. So this would be the answer to the problem. If we wanted to know the dimensions of the printed area, then we would use the 11. But it says, what is the minimum area? Okay. Now, did you notice how when I graphed it at first and I didn't see anything, I didn't panic? I don't panic. What do? Just change my window. And I keep changing it until I get it right. Until I see what I need to see. All right, C, problem C. Henry can complete the thing. Sean helps him and get it done. How long would it take Sean to do the assignment? We talked about these the other day, didn't we? Did we talk about these the other day? No? All right, then I better give you a little formula then. You know how when we do mixture problems, you know, I got 58% lemonade and 20% lemonade, and I gave you that little kind of formula-like thing, amount times percent plus amount times percent equals amount times percent. Well, there's like a little formula type thing for these problems that say somebody can do a job. It takes, you know, Billy this long to do it. It takes Susie this long to do it. How long would it take them to do it together? It's 1 over alone plus 1 over alone equals 1 over together. You did these in first year algebra. So if you had a different strategy that you remember from first year algebra, I am fine with it. The idea is we want to get the answer. But this is how I always set them up. So if I got 2 people doing a job together, then 1 over the first guy's time alone plus 1 over the second guy's time alone is 1 over their time together. All right? So here we go. Henry can do it in 6.5. So 1 over 6.5 plus 1 over X, because I don't know Sean's time alone, but I know their time together is 4. Now, how you solve that is completely up to you. You will have a calculator. You will have a calculator for this problem, so whatever works for you. Personally, I'm going to multiply through by 26x. Now, why am I multiplying through by 26x? Of all the numbers in the world, it's the common denominator, right? It's the common denominator. So this is going to leave me with 4x The 6.5 goes into 26 4 times. This is going to leave me with just 26. And this is going to leave me with 6.5x. So 26 equals 2.5x. And x equals whatever 26 divided by 2.5 is. Thank you. 10.4? So it takes him 10.4 hours to do the job alone. Is that okay with everybody? They're never any harder than that, by the way. They're always pretty simple. All right, problem B. Bob likes his lemonade to be 27%. Max likes his to be 15. What will be the percentage of water in a pitcher if Bob dumps in 18 ounces of his lemonade and Max contributes 28 ounces? Oh, this one's a little bit different. But let's see if we can figure it out. All right, here we go. What goes where? Okay, so this will be Bob's, and this will be Max's. Okay, so Bob likes his lemonade to be 27%, and Max likes his to be 15%. And I don't know the percentage of the final mixture, but I know that Bob is giving 18 ounces, and Max is giving 28 ounces. So what goes here? 46. If somebody's dumping in 18 and somebody else is dumping in 28, doesn't that give us 46 ounces? So the question is different. I don't remember ever doing one that was this way, but the format is exactly the same. Our variable is just in a different spot than it normally is. Is that okay with everybody? Just plugging in the numbers. Okay, so what does this equal? 18 times 0.27 plus 28 times 0.15 is 9.06 divided by 46. I get about 19.7%. It says, what is the percentage? I would say 19.7, would you? Is that what you got? Okay, now we're going to make a box. I'm on A now. All right, Lauren's creating a box to hold all the stuff. She's making the box from a piece of paper that's 24 by 30. 24 by 30. We're going to cut the corners out, you know, the way we always do it. The box must have a volume of at least, so the volume has to be greater than or equal to 1,000. The volume must be at least 1,000, greater than or equal to 1,000. Okay, how big must the cutouts be, and what is the domain of this problem? Well, you're going to need the domain in order to set up your window, right? Because your domain is going to be X min and X max. If the paper is 24 by 30, what is X min and X max? You already know that. We've talked about this a zillion times. X min is X min is 0. X max would be 12. Always half the smallest dimension because you're taking an X off each side, so it can't be more than half. So that's X min and max. Now, what's my equation? Let's get that down here because we're going to have to be graphing this thing on our calculator. So what's my equation going to be? What's the volume? 24 minus 2x, 30 minus 2x, and x. Now what I'm going to do is, I'm not going to do it that way, I'm going to go ahead and put in 2 equations in my calculator. I'm going to put this one in, and then I'm just going to put in 1,000. So I'm going to go ahead and graph, oops, I'm going to put in this equation right here. And then I'm going to put in a second equation, y2, that's 1,000. Then I'm going to go to my window, and I'm going to make my x-min and max match this. And then y-min will be 0, of course, because the volume can't be negative. But y-max is going to have to be more than 1,000. So I'm going to go ahead and make it 1,500 just for fun. And hit graph. Now, what I saw on my picture is this. Is that what you saw? That's what you need to see. So make sure your y-max is something bigger than 1,000. And this is the 1,000 line right here. We graph the 1,000 line. Now, we want the volume to be more than 1,000. So where am I looking here? So right here is where it equals 1,000, right? It's more than 1,000 here. So I need to find those 2 points. I can find those 2 points using second calc, can I? And then what? Intersect. So second calc intersect. Set your bounds just like you always do. On either side of the point of intersection. And that first one is about 1.88 if I did it right. Anybody match that? Somebody? Anybody? Yeah. Now I'm finding the other one. I need them both. And it's about 7.56. So those are the places where the volume exactly equals 1,000. All right, where will it be more than 1,000? And how will I express that answer? Everything in between those two? Would that be okay? Now, did I answer the question? The question was, how big must the cutouts be? These are X values, right? And that's what the cutouts are. So how big must the cutouts be? Anywhere between 1.88 on a side and 7.56 on a side. Anything in there will make a box bigger than 1,000. All right, anybody have a question about that? Okay, let's look at part 4. What are the excluded values? Remember, excluded values are anything that makes the denominator 0. So look at problem A. What would be the excluded values? 0 and -4. If you factor your denominator, which I would highly recommend, you can see that your zeros would be at 0 and -4. How about B?
True, -3.
Watch it. It's a trick question because I mean. There aren't any excluded values. Will the denominator ever be 0? No, not in real number land. Now certainly we could have a negative, I mean we could have an I involved, but we're not not going to do that. We're going to keep it real. So there are no excluded values for problem B. Everybody see that now? What would make that 0? Anything you square is going to be positive, and when you add it to 9, it's still positive. Right? You can't make it 0. What about C? The only excluded value is 0. Yep. All right, number 3. Find the end behavior asymptote. Now, end behavior asymptotes can be horizontal. Is this one going to be horizontal? No. Because why? The top power is bigger. Now, you're not asked to do anything with this except find the end behavior asymptote. So what are you going to do? You're going to divide. You're going to put a 3 out here, these numbers across the top, and here we go. Did I divide right? So what goes in the answer blank? End behavior asymptote. Y equals 2x plus 2. And that's all that you have to do with that one.
The one you put in the box is always what makes the denominator 0,
Yep.
right?
Yep. And it's the same that, remember when we were graphing, Sam, and you had something like this, and you went to the number line. Whatever dots you would put on the number line is the number you divide by.
Okay.
So you'd put a 3 on the number line, so if I were dividing by this, I'd divide by 3. Okay? Now, we got tons of time. Let's just finish this sheet. Number 2. All right, we got a lot of work to do with number 2, so here we go. We'll get this sheet done for you then. That doesn't mean you shouldn't get it back out and look at it again, though. Okay, so x squared plus 3x. I'm taking a 3 out because I know that when I start one of these problems and I'm asked for asymptotes and holes and all that stuff, my first step should always be to factor. So that's what I'm doing. I'm factoring. And it's a very good thing I did, because what do I notice? I am going to have a hole, because these are going to cancel, assuming I factored correctly. And this now is the focus of all my attention. That's what I'm looking at. I'm no longer concerned with the original problem. I am looking at this. I'm going to go ahead and graph my hole so I don't forget. Where is that hole going to be? Where x is 2. Now I'll plug 2 in. 21/4. Great. All right. So we're going to plot it at 2, 21/4. So 21/4. Here we go. 1, 2, 3, 4. Nice little open dot. There we are. Now we got to put in all the other stuff that we always put in. So, Patty, give me something. Give me something else to graph. I got my hole taken care of. What else?
We're going to need the vertical asymptote, which is at x equals -2.
You are right on target. Thank you.
Also,
go ahead.
we might need an end behavior asymptote.
We might need an end behavior asymptote.
I think we will.
You think we will? Yeah. Do you have any idea where it is?
I want to say it's horizontal, but I'm not sure
No.
where.
Okay. Well, you're right. It's horizontal. How do we know this asymptote's going to be horizontal, Katie? Yep.
The powers match.
They're both x squared. So where do you know where the asymptote is? Y equals 3. Because we have, if you look at the original problem, we have 3x squared over x squared. If you look at the reduced problem, we have 3x over x. So I have a horizontal asymptote at 3. That is exactly right. All right, Patty, you're on a roll. You want to answer anything else, or are you done?
Well, y-intercept.
Y-intercept? Where would it be?
I'm just doing a little calculation in my brain. Y equals... Sorry. 15 over negative 2.
Actually, positive 2? That is 15 over 2?
Oh, 15 over positive 2. My
Yep.
bad.
1, 2, 3, 4, 5, 6, 7.5. It's right there. 0, comma 15 halves. Perfect. How did he find the y-intercept, kids? You hear him doing the arithmetic out loud? He put 0 in for x. That's how we find y-intercepts.
And likewise, we can find x-intercept, so 0 is the
Yep.
similar way. Just plug in y equals 0.
So if we let this be 0, this is going to disappear, right? And I'm going to solve that, so it looks like x is negative 5. Is that enough?
That's enough. Still graphing.
Can we graph it based on this, guys? I think you can. I hope you can. Does that look okay? Now, I'm going to go ahead. They aren't listed, but I'm going to go ahead and ask you a few questions about this. So just make a note of these over to the side. Let's see if we can answer these questions. We'll find the limit as x approaches infinity, negative infinity, negative 2 from the positive side, 2 from the negative side. I'm just making these up. There's nothing special about them. One. And 0. Alright, so let's answer these questions. I'll number them. And tell me if you have the answer to one of them. If you know the answer to any of those, tell me. What do you think? It's closer to 3 from the top. Very good, Trey. As x approaches infinity, we look out this way, right? What is our curve doing? What is happening to y? Y is getting smaller and smaller and smaller, but not smaller and smaller to infinity. It's getting smaller and smaller toward 3 from the top. As opposed to on the other end, is this also getting closer to 3? But it's getting closer to 3 from the bottom. Okay? When you take your calculus class, they're going to give you this kind of information, and you're going to have to sketch the picture from the limits, not from the equation. You're not going to have the equation. You're going to have to be able to interpret this so that you can put a graph together. All right, so what can you tell me about anything else? Can you tell the answers to any of the rest of these? Evie? This one? You said positive infinity. She's exactly right. Look, at negative 2, we have an asymptote. As we approach that asymptote from the right side, what is the curve doing? It's heading up. It's heading up. Now, some of you say, well, this curve's heading up too. Yes, this one's heading up, but it has a cap. This one's heading up, and it doesn't have a cap. So it just goes to infinity. All right, how about one of the other ones? Now watch it. This is a 2, not a negative 2. So as we approach 2 from either direction, the answer is 21 over 4. When you approach a point, no matter which direction you're coming from, so you can ignore this because that's a point. X equals 2 is a point. It's an open point, but it's still a point. So the limit's going to be the y value. Okay? All right, what about these guys? This, what is 6 going to be? What is the answer to this?
15
That's a point. So the answer is 15 halves. What about that? That's a point, isn't it? Isn't x equal 1 some point on the graph? Now I don't know what point it is, so I have to figure that out. But that's the point 1 comma what? How would I figure it out?
Plug 1 in.
Plug 1 in. And when I plug 1 in, I get 18 over 3. I get 6. So the answer to this one is 6. Got it? All right, we have 5 solved problems, and I think we can get them all done, but I'm not sure. So look at the 5 solved problems and which one is most pressing to you. A through D are no calculator. E is a calculator. You'll have it on a calculator part. So which one is most pressing? E. All right, so we need our calculators out. And for solving an equation like this that is not a word problem, I would go ahead and start with the standard window. Now, that may or may not work, but that's a good starting place. So I'm going to use a standard window. And I'm going to type in, take out those other equations and type this in. Exactly, oh, actually, I'll move that 2 over. I didn't notice that 2 was on the other side. So I'm going to move the 2 over. So I have a 0. So x squared plus 8 divided by x minus 2. And I hit graph. Now, in a standard window, the shape I got looks something like this. More or less, is that what you got? All right, now let's talk about this for a minute. We are looking for the places where this curve is bigger than 0. Now, or equal to. Would you agree that it's equal to 0 right there? So where is it more than 0? Wouldn't it be this piece right here? And this piece right here, isn't that piece also bigger than 0? In fact, anything above my arm is bigger than 0. So in order to answer the question, I need to locate that point. So how will I do that? Second calc, 0. Now look, just today, we've used second calc 3 ways. We've used it now to find the 0, we used it to find a minimum, and we used it to find the point of intersection. Second calc, very useful. One of our favorite buttons. Alright, so I came up with negative 2.33, did you? Now, you're ready to write your answer, believe it or not. Okay, so tell me about the red curve, the x values that we're writing down, x values. Tell me about this. How am I going to describe that? What's that?
Negative infinity.
Negative infinity. to negative 2.33. That's this chunk right here. Or, okay, now this is a little bit tricky. Can you recognize by looking at the equation that there's an asymptote at x equals 0? Your calculator doesn't draw that asymptote in, but can you recognize that there is an asymptote there? So would you agree we have everything from 0 to infinity over here on this side? Starting at 0, everything else is above the x, above the x-axis. Okay, all right, what's next most pressing? We got that one done. These rest are all no calculator, so what else? D. Now, as I copy D down, I am going to factor that last thing. Okay, so that last fraction, I went ahead and factored that denominator. Now you solve this however you want. Your job is to get x. I'm going to multiply everything by x minus 2, x plus 1. And that's everything, even the 4. Now, it's a lot of writing, I know, to write that down for each term, but it makes it so much easier because, can you see things canceling? So now I'm going to FOIL these two together, so that's x squared minus 4x plus 4. I FOIL these two together, what's left? Alright, then plus, right, those are going to cancel, so that's 3x squared plus 3x if I distribute, equals, alright, I'm going to have to carry it down here. This will be 4 times x squared minus x minus 2, FOILing that out. Then I'll have to distribute, I just couldn't do it all at once. Plus, it all cancels and leaves me with 3. Everybody okay? Now it's just a simple little equation. Here we go. Let's clean this up. What have I got? 4x squared minus x plus 4 equals 4x squared minus 4x minus 5. I have a minus 8 and a plus 3. Well, that's nice. I thought it was going to be quadratic, but these are going to cancel, aren't they? So 3x equals negative 9, x equals negative 3. Be careful. What do I always kind of have to keep an eye out for on these problems? Extraneous roots, right? Your excluded values. No problem here because your excluded values would be negative 1 and 2, and I didn't get that. So my answer is negative 3. Okay? That wasn't too bad. All right, anything else pressing? We are down to A, B, and C. All right, C. We're going to subtract the 2, right? Please don't not subtract the 2. We're going to subtract the 2. And then what? Common denominator, which will be x plus 4. So I have x plus 4 on the bottom, x minus 3 minus 2x minus 8 on the top. Watch that distributive there. So negative x minus 11 over x plus 4 is greater than 0. More?
Why wouldn't you just like multiply the x plus 4 over in the beginning?
Somebody want to explain that to her? It's an inequality. We cannot multiply it unless we know for sure we're multiplying by a positive or a negative, because the sign changes sometimes. Now, what do I do next? Once I get down to one fraction, you know, I got my common denominator, I collected all my like terms. What do I do when I get down to one fraction? I draw the number line. Now, everybody can see this dot. It's real obvious. We're not going to just guess numbers. If you don't know where to put this dot, over to the side, set it equal to 0 and solve it, and it looks like the dot is at negative 11. Now that's an or equal to, so something should be filled in. The negative 11 is filled in, never denominators. Denominator dots are never colored in. And then we will guess a number, pick a number, and 0 will work. Now remember, 0's out here. So let's put 0 in and see what we get. If we put in 0, we get negative 11/4. Is that what we were hoping for? No. Greater than 0 means positive. You got a negative 11/4. That means it's not good. So that didn't work, which means this one does. And your answer is everything from negative 11 to negative 4. All right, maybe we can get the last two done real quick. Here we go. What's my strategy for B? Oh, yep, get 0. We always want to get 0 with our inequalities. So I'll move everything over. And then what? Yeah, I gotta get it factored. I gotta get it factored. If it doesn't factor by grouping, which it doesn't, I'm gonna do the whole PRR thing. Now, I can tell one works. You might try a number that doesn't work, so then you'll try another one. You'll just keep trying numbers until you get one that works. I promise on a test, I'm not going to give you something where you have to make 18 tries. You'll get it within the first couple. Okay, so where do I go from here? I guessed one that worked. The number 1 works. So what I have left is x squared plus 6x plus 8, which factors as x plus 4, x plus 2. But do not forget, that's a factor. What factor is that? X minus 1. Don't forget him. If it's an x cubed, you got to have 3 factors. X to get x cubed. So that is less than or equal to 0. So what now? Number line. And put the dots on the number line. This time there's 3 of them. Make sure you get them in the correct order. It's not the order of the parentheses. Make sure they're in number line order. How about those dots? Solid or colored in? Or solid or open? They're all solid. Want to try 0? It's right here. So if I put 0 in, I get negative 1 times 4 times 2. Negative 1 times 4 times 2. Is that what I want? Mm-hmm. Yep, so that works. That doesn't, this does. So my answer is everything from negative infinity to negative 4, or negative 2 to 1. and 1 to go, and this sheet's done. How about that? X squared minus 8x greater than 0. Remember, the first step when you're doing an inequality, you really would like to have it equal to 0, unless you're graphing it on your calculator. Then it's a different, then you got more options. But if you're doing this by hand, you want to get that 0 over there. All right, and then what?
Factor X out.
Factor out an x.
X equals 0.
You got 2 dots on the number line. One's at 0, one's at 8. Open dots on the number line. Now we almost always, we've been using 0 as a checkpoint. You can't use it this time because it's a dot. So you'll pick another point. It doesn't matter. Anything except 0 and 8. 1. So 1's in here. 1 would give me 1 times negative 7. Is that what you hoped? No, this is positive. 1 times negative 7 is not positive. So that doesn't work, which means this does and this does. So negative infinity to 0 or 8 to infinity is your answer. Okay, so what do you have to do for Monday? I just did review 2 for you. You need to do review 1 if you haven't done it already. It is videoed, so as you're working through it, if you get stuck on something, you can just go back and find it, keep working it out, okay? Good work, everyone. This is our Friday.